Okay, welcome to my YouTube channel. Welcome back to DET tutorial. In this video, we'll look at the oxidation number of elements. Oxidation number of elements. So the oxidation number of an element is the electrical charge it appears to have both in free and combined states. The charge an element possesses, or the charge it has, it appears to have both in free, when it is free, and when it is in combined state. That charge is referred to as the oxidation number of that element. So the oxidation number of an element is the electrical charge. It is the electrical charge it appears to have both in free and combined states. So that electrical charge an element appears to have both in free and combined state is known as oxidation number. Oxidation number. And what we're basically concerned about in this video, or what we are going to look at, is how to calculate the oxidation number of different elements. And there are certain rules that are involved. So these are the rules in calculating, or these are the rules for calculating the oxidation number of elements. So the first rule here is the oxidation number of an element in the uncombined state is 0. That is very important. The oxidation number of element in the uncombined state, that is when the element is uncombined or when the element is free, the oxidation number is 0. This is very important. The oxidation number of element in the uncombined state is 0. So this rule 1 is very important. The oxidation number of elements in the uncombined state is 0. So according to rule 1, all elements in the uncombined state have an oxidation number of 0. This is what rule 1 is all about, that the oxidation number of elements in the uncombined state, provided the element is in the uncombined state, the oxidation number is 0. So in other words, all elements in the uncombined state, when you are free, they will usually have an oxidation number of 0. So these are different elements in uncombined state. This is sodium, potassium, nitrogen, hydrogen, phosphorus, oxygen, ozone, sulfur, magnesium, aluminum, carbon. So all these elements, if we're asked to calculate their oxidation number is 0 because they exist in the uncombined state. So sodium is uncombined, it's just an element, so the oxidation number is equal to 0. Potassium is uncombined, so the oxidation number is equal to 0. Nitrogen is uncombined, so the oxidation number is equal to 0. It's just nitrogen. There is no other element that is attached to it. So hydrogen is just alone, and so the oxidation number is 0. Phosphorus is uncombined. There is nothing combined with it. There is no element attached to it here, so the oxidation number is 0. Oxygen, the oxidation number is 0. Ozone, the oxidation number is 0. Sulfur, the oxidation number is 0. Magnesium, the oxidation number is 0. Aluminum, the oxidation number is 0. Carbon, the oxidation number is 0. So all elements in the uncombined state, provided it is in the uncombined state, the oxidation number is equal to 0. This is what rule 1 is all about. To take us further, let's look at this question. In which of the following is the oxidation number of sodium equal to 0? In which of the following is the oxidation number of sodium equal to 0? So this is sodium Na. So in which of these substances, or in which of these compounds, is the oxidation number of sodium equal to 0? So option A is sodium tetraoxosulfate 6. Option B is sodium trisulcarbonate 4. Option C is sodium. Then option D is sodium chloride. So like what we said before, that all elements in the uncombined state have an oxidation number of 0. So, and we're looking for the option whose oxidation number of sodium is equal to 0. So option A is not the answer because sodium is combined with other elements, and so the oxidation number of sodium in this compound is not 0. Option B is not the answer because sodium is combined with carbon, is also combined with oxygen, so it is not alone. Option C is the correct answer. because sodium is existing as a free element in the uncombined state, and so it has an oxidation number of 0. This is sodium chloride. Sodium is bonded to chlorine, and so it does not have an oxidation number of 0. So this is wrong. So in which of the following is the oxidation number of sodium equal to 0? It is option C. Why is it so? Because all elements in the uncombined state have an oxidation number of 0. So sodium here is uncombined, is not combined to any other element, and so the oxidation number is equal to 0. So for more clarification, let's look at this other question. In which of the following is the oxidation number of oxygen equal to 0? In which of the following is the oxidation number of oxygen equal to 0? So we have sodium tetraoxide 6, we have sodium triacylcarbonate 4, we have oxygen, and then we have water. So just remember the first rule, that all elements in the uncombined state have an oxidation number of 0. So which of them is oxygen having an oxidation number of 0? Which of these options is oxygen having an oxidation number of 0? So oxygen is combined with other elements here, and so the oxidation number is not 0. So this is not the answer. Oxygen is combined with other elements here, and so the oxidation number is not 0. Oxygen here is alone, is not combined with any other element, and so this is the answer. So, and here water, we have oxygen being bonded to hydrogen, so it is not alone, and so the oxidation number is not 0. So the option that is having an oxidation number of 0 is option C, oxygen in the uncombined state. So which of the following is the oxidation number of oxygen equal to 0? Is option C, because it is uncombined, just oxygen. So moving on, the next rule that we're going to look at is rule 2. So we have looked at the first one in calculating the oxidation number of elements. I will say that the oxidation number of elements in the uncombined state is 0. We've established that already. So the second rule that we have here is the oxidation number of a simple ion is the same as the charge of the ion. The oxidation number of a simple ion is the same as the charge of the ion. So this is what rule 2 is all about, that the oxidation number of a simple ion, is the same as the charge of the ion. It is the same as the charge of the ion. So these are different ions, and these are the charges they carry. So what rule 2 is trying to say is that the oxidation number of each of these elements or each of these ions is the same as the charge of the ion. So for potassium that is having a charge of plus, the oxidation number is +1. For sodium that is having a charge of plus, the oxidation number is +1. For magnesium that is having a charge of +2, the oxidation number is +2. For calcium that is having a charge of +2, the oxidation number is +2. So the oxidation number of a simple ion is the same as the charge of the ion. So the oxidation number is equal to the charge of the ion. That is what rule 2 is all about. So the oxidation number of this aluminum that is having a charge of +3 is +3. The oxidation number of zinc ion is +2. The oxidation number of chlorine ion is -1 because it's having a charge of what? minus. The oxidation number of hydrogen is +1 because it is having a charge of plus. The oxidation number of oxygen ion is -2. The oxidation number of fluoride ion or fluorine ion is -1. The oxidation number of copper 2 ion is +2. So what rule 2 is all about is that the oxidation number of a simple ion, these are simple ion, is the same as the charge of the ion. So the oxidation number is equal to the charge of the ion. So potassium ion having a charge of plus, the oxidation number is +1. So they are just equivalent. So let's look at this question. The oxidation number of aluminum ion is the oxidation number of aluminum ion is. So from rule 2, we said that the oxidation number of a simple ion is the same as the charge of the ion. So it is having a charge of +3. That makes the oxidation number to be +3. So option B is the correct answer. Then the oxidation number of chlorine is ion is. So like we said before, from rule 2, the oxidation number of a simple ion is the same as the charge of the ion. So chlorine is having a charge of minus, and so that makes the oxidation number to be -1. So our correct answer to this question is option A. Why is it so? Why is it -1? It is -1 because chlorine is having a charge of -1 minus. And like we said from rule 2, that the oxidation number of a simple ion is the same as the charge of the ion. Chlorine is having a charge of minus, and so the oxidation number is -1. So rule 2 is the oxidation number of a simple ion is the same as the charge of the ion. Very simple rule to remember. Then we have, moving on now, we'll look at rule 3, and rule 3 states that the sum of the oxidation number of the elements in a compound is 0. The sum of the oxidation numbers of the elements in a compound is 0. So in the next video, we'll continue with this rule 3.